invite all the keynote speakers to activate their microphone and to activate the camera too. So I think we have mainly everybody there. Yeah, that's the facts. So I hope this will be an open discussion, talk to each other. I will just initiate some points. And for sure, the first point I would like to address is what is the impact from a Swiss perspective, but also from a European perspective of the exclusion of Switzerland from the European Horizon Europe program. Perhaps I would first have the answer from the Swiss perspective. So perhaps Alexandre or Grégoire, you can answer that. But then I would also have the opinion from our partners in Europe. What are the implications? Perhaps let's start by Alexandre or by Grégoire. How do you see that? What are the impacts?
Sure. As mentioned already, one impact is the fact that we cannot lead projects anymore, and we cannot even participate in EU projects at the moment. So this is certainly a big blow. And the second I see is for the SMEs, the companies that used to get funding in the current Horizon program and that will not be able to get any funding in the new program. And I think I see this also as a very negative measure, and also a negative sign for them, because they need to be involved so that they contribute to the next developments.
Can we have an estimation of what funding, or what are the amounts we are talking about for Switzerland? What kind of impact does it have in terms of numbers?
So for the whole Switzerland, I don't know. I know that for CSEM, we have a budget of 12 million this year for EU projects. I think probably 30% of that goes to quantum and space. So we'll be certainly losing a few millions there longer term. The last time when it happened in 2014, it took about 5 years for a full recovery. And at the peak, we lost 40% of the EU revenues. Now, I'm just talking about CSEM. I don't know the impact for all other RTOs, which is certainly much larger.
And Grégoire, from your perspective as an industry?
So you asked two questions. First, the impact for Europe, and then the impact for Switzerland. So I'll be a bit provocative. I think the impact for Europe is nothing, and I want to be provocative here. We have excellent science, but it can be replicated, and smart people will go where the conditions are the best to do the best science. So now, impact for SMEs, it's dramatic in Switzerland because, as you may know, there are no other ways to get R&D funding into companies in Switzerland than European projects. And so for IDQ, to give you an idea, we've had funding across several framework programs. And at times we had up to 4 or 5 people that were funded by European project. And that's when the team was maybe 15 people. So, you know, all the R&D of the team was funded by some such project. And I would say on average on the past 20 years, we've had 2 to 3 people in our R&D team funded by such project, working on things that we could not afford otherwise, because kind of forward-looking research. So I think a dramatic impact. And I would say, you know, today, if you want to start a company in quantum, as of today, don't do it in Switzerland. Go somewhere else. There are better places in Europe. And again, I want to be provocative.
I think we should also not forget the impact on the QKD, so QDT, sorry, Key Digital Technologies in Europe, which is also a program that is heavily funded, in which we will not be able to participate.
Okay, now from a perspective from our European partners, does somebody want, or Carl, do you want to have a...
So again, one of the things that we have done in the US, and NIST did this, was to establish an industrial consortium. And if you go in and you talk to the big companies, including companies like IBM, who is a member of our consortium, but also help sponsor your day here, companies will tell you today that they are global and that their supply chains are global. And I think the failure to be global is the failure to use all the resources available to you. So that those resources include that not all the brains in the world are in any one country. Switzerland, again, is a small country, but it hits far above its weight in the quantum arena. If you look at it relative to gross domestic product or relative to population size, you are a major player in the quantum world. So being left out is something that shouldn't happen. I mean, you would always be welcome to engage with the US. And in fact, we want to engage globally. We think it's important. We don't think we have all the ideas. We don't have all the workforce we need. And through global engagement, we basically leverage the thoughts, the ideas, and the smarts from around the world. And so we really believe in a global environment and believe that being global is essential to competing today.
Thanks, Carl.
Maybe I can add to that, that of course, as a scientist, I regret a lot that there are somewhat artificial boundaries right now that make it more difficult for us to collaborate with people whom we would like to collaborate with because they have complementary information. These are people with whom we can work well. Seeing this happening is sad and is certainly not helping science in general. If we think about what I think for Europe, there is still, what Gregor said is probably correct, that if Switzerland doesn't manage to somehow master right now the lack of funding and maybe create their own federal resources or resources for funding, there could be a brain drain and people may leave and go to Europe. I hope this won't happen. I hope Switzerland can stop that before, because it would be indeed sad. I think for Europe, it's kind of not having Switzerland as the country that is, at least in QKD, the one that is the furthest developed. I think if there's one country in Europe that could simply roll out a QKD system, well, that is in Switzerland. I think, Gregor, you probably don't correct me if I say, well, Quantique has everything to do this right now if the funding was there. So right now, Europe's saying, well, we want to compete internationally, but we don't want the country to be involved. Who can actually do it? Yeah, I find that a little bit surprising.
Other opinion on the?
Yeah, maybe I can add, so I can speak with both hats, SAP and with Quick. I think also personally, I think it's a pity because and as we are building up consortia for the new Horizon Europe program, this is really bugging us, and we are running late because our usual partners are the one who could be very, I mean, give a good input for a specific proposal, you know, decline or because of those no funding. Of course, they can still participate, but no funding is not making attractive. I think it definitely impacts the SMEs, as my colleague said, and same as Carl mentioned. I mean, for big companies, it's not really changing a lot, but that's a pity in terms of ecosystem, etc. And from a quick point of view, this is also why from the start, from the beginning, we said, okay, we go, it's really European in the broad sense. We value what happens in Switzerland, what happens in UK, what happens in other countries that are not part of the 27. And I think, I mean, we have to collaborate. This ecosystem exists. And will continue whatever happens on the politics anyway. So that's a pity, but hopefully, I hope it will not be a complete stop of this collaboration.
Yeah, if I can comment on that, you're right, Laure, that at some point the big consortia, mainly for quantum computing, quantum simulation, and quantum secured communication, they are handled in a different way than quantum sensing in Horizon Europe. So there is this way of doing FPA, SGA. I don't know if you know these things, but once you create big consortia in the FPA, then this consortia will be selected and they will have then to implement what will be done in the next 2-3 years. So it means the big consortia that are set up now for these fields, they will exclude Switzerland, and this means they will exclude them for the 6-7 years to come. And this is, I think, more dramatic even than quantum sensing, where somehow the projects are lasting 3 years, and let's say we will have a gap of 2-3 years. I don't know if you share this opinion, and perhaps we ask the Commission if at some point this FPA, once the consortia are built, are they still open to accept Swiss partners in the implementation phase? And for that, we didn't get a real answer.
So it's a difficult situation, but I think it's still not impossible to collaborate. By example, we could do it by subcontracting. We could also ask the German Science Foundation for initiating bilateral cooperation between, by example, Germany and Switzerland. I think we have to take the situation like it is, at least for the next couple of years, and make the best of it. Because for my feeling, because I'm living in Freiburg, there is an invisible wall behind me, which I don't like, because it weakens Europe and also the ecosystem we are looking for. Because if we talk about competitor, it's not the Swiss. Yeah, it's somewhere else where the strength is. And therefore, I think as long as the scientists are a little bit more clever than the bureaucracy, we should find ways for collaboration.
Yeah, I think we've seen the national initiatives in France, in Germany, in Italy, everywhere, in the UK. And yeah, we should profit from this national initiative to start bilateral discussions and to reserve some of this amount perhaps for bilateral projects. Let's think about that and try to do that in the near future. Perhaps
maybe one question. You're talking about national initiative in France, Germany. What about Switzerland? No national initiative, and we're being kicked out from the European programs. It seems the timing is bad, and that the Swiss government really wants us not to lead in this field. And again, I want to be provocative.
We need one.
And we have this national chapter about Switzerland inside QuiC, so that would be a good way to, you know, prepare something and turn back to the government and explain what will be the ideal situation.
I think there are some discussions in the ETH domain, so hopefully it will go in this direction very soon, and we can all pull at the same string.
So, you know, I'll come back. I can go into any university in the US, same as I can go to any university in Switzerland. You know, none of us are subject matter experts. We're not all born in the country we live in. And you know, the world wins by being open and sharing. I think, you know, yes, companies compete, others need to compete. But it is really important that we do this in a global way, trusted, respect, and everything else, because I believe that the future is more openness, not putting fake barriers behind us in between countries.
We have a question from the audience that is related, and the question is, how important is it for companies to fully own their IP in research collaboration? Sovereignty of IP rights owned, licensed to the EC. So it's a big question about IP, who owns, and also companies with headquarters not in Europe are also banned from the Horizon Europe. What are you feeling about how should we handle IP?
So I will go, you know, you can go to any large system integrator and again, you can look in the semiconductor industry. You know, there's a company up in the Netherlands that produces a lot of the equipment that every fab has. There's a company, if you look at modern technology, no company owns all the IP in its big complex project, whether this is an airplane, a computer, a smartphone, or anything else. And to think it's all about one company is the wrong way to approach it. Now, again, all companies need to have intellectual property to have value. But I think, again, it is an ecosystem, and we need to work in that ecosystem.
I agree with what Carl said. So indeed, you know, companies, somehow when you look for investors are always worried that the company may one day face challenges. And if the company goes down, then what's left? IP, you know, IP is maybe something that could be sold and still would maintain value. And so you need to have some IP. It could be through a license, it could be through by owning IP. I think it doesn't really matter, provided that you have a good arrangement. Now to talk a bit about the nationality aspects, I agree with what Carl said. Indeed, in all the large industries, there's no IP spread across the different companies and countries. That's very true. We face a bit of a challenge with quantum technologies because politicians see a new industry being born, and it doesn't happen so often. And so politicians want their country to have a share of the cake that's going to be created by this new industry. And so they apply, their thinking is incorrect because they think national approaches, they think local companies. And so I think it's a sign of the lack of maturity of this industry, and that we're going to have a phase of a few years where it will be very nationalistic, unfortunately. And eventually, when the market becomes mature enough, we'll end up again with global companies, and that won't be a topic anymore.
Well, thanks for, I think we'll change a little bit the topic. So we discussed sufficiently about Switzerland and EU. I would have one question. We've seen that quantum sensing is more advanced than the others in terms of commercialization. So we see products, we see miniaturization, atomic clocks, magnetometers, and so on. There was a lot of promises from the quantum computer, and now we see that this happens. So there are quantum computers running that can be used by users. Question, do you see somehow quantum computers at the end, in a very far future, being integrated in consumer devices? We discussed that somehow the gates or the qubits, they are being so small, 1 to 2 nanometers, if you see ions separation between them. So meaning if we have now the processes technology, which are down to 12 nanometers, I guess we are not so far from that. Do you think somehow at some point we will have processes based on quantum or on qubits?
I hope so. We may be retired by that time, all of us, by the way. But I think that this could be one of the objectives. And I mean, here I'm talking as a user. I'm not building and I'm not really knowledgeable in all those hardware aspects. But as a software user, this is what we want to achieve in the long term. So there will be intermediate step where there will be. So I consider today what is available is more research mode or prototype or whatever you call it. At some point, we will have something live, and considering the size, considering all the constraints, we will have it in some computer center when you access through cloud, etc. So this is where the communication are important. But ultimately, what I would like to see is, so maybe not yet in the laptop, but at some point, same way you have a CPU and a GPU, you will have next to it a QPU, a quantum processor unit. And this being completely transparent to the user and even to the application developer, where, you know, depending on what you are doing, this will use the best of the breed. I mean, we'll use what is really, we'll use the QPU if it's, I don't know, for some optimization or machine learning that is requiring this type of technology, and vice versa, and go back and forth between those two. So that's, that's the dream, obviously, but that's what we should look at in the future. But how many years? I have no clue.
So all I would do is, and I would show my age again. You know, if you had asked me in 1990, there was one of the most powerful computers around was a Cray. You asked me in 1990, would I ever be carrying a Cray around in my pocket? I would have told you you're nuts. But of course, I have one because the processor in my smartphone is more powerful than the Cray. Quantum technology is what we can do with modern physics at the best level. It will get miniaturized. Do I know whether we can connect all the devices and everything else? What's the throughput of a quantum network? Everything else. I don't know all the answers to those. I like the relativistic geodesy kind of things, whether it's for earthquakes or for volcanoes, in part because it's not pointing to what something I know will happen, but something that might happen. And so I think we really have no clue how all this technology is going to be used. where it's going to have its main applications, how it's going to impact society. I think any of us who can be that visionary would go out and start our big company. And as I put on that first slide of mine, quantum games and toys, if I can put it into the smartphone, that correlated random number generator is a multi-billion-dollar market. So I think we just have to see how it plays out, but I assume that it's going to happen because it can.
Good.
Yeah, I think one other thing is probably that right now we are thinking of a quantum computer as a quite big device, and we are wondering, well, will it ever fit into our smartphone? But I think if we get to a level where we can really optically connect to a quantum computer that is somewhere else, well, whatever has to go in here is actually quite simple. There is not a lot. I think this exists already. This can already be done. What is missing is all the steps in between. The computer can be somewhere else. And we see that also in the classical world, that we don't have all the computations happening locally on our devices anymore. They're somewhere else. So I think if we don't consider computation and communication as two different pairs of shoes, but it's kind of the same thing and they have to work together, I think then we really can think about consumer devices that take advantage of quantum because everything is connected in a quantum manner.
I think it's very important to convince our citizens that what we do, where the money is invested for research, for education, that the final goal is to have somebody that is made for them, for the technology, and at the end, the citizen will benefit of that. With that, I think we will close this panel discussion. I would like to thank all the keynote speakers for the time they dedicated to this Quantum Industry Day in Switzerland, for participating also to this panel discussion. I would like also to thank my team for organizing all the events on the materials point of view. Everything went well, except we had some sound issue at some point with Laure, but it was on my side, not on your side, Laure. Also willing to thank the organization committee, so the QIDiS sponsors for making it possible on a financing point of view. And I would like to go back to the presentation, Nicola, just to highlight the following steps of Quantum Industry Day in Switzerland. So we have, just after that, at 12:15, the session A on building a quantum career. Very interesting. Please go there and listen to these people that went their career in quantum. And then for the others that take a break, we start again at 2 p.m. So session B on quantum instrumentation, session C on quantum computing, session D on quantum safe security, and session E on quantum sensors. You find all the links to access this webinar on the QIDiS website, and you will be directly linked to the webinar starting at 2. With that, I thank you again. I thank also all the attendees, and I hope you enjoyed the session here, and you will enjoy the next session. And finally, save the date. Next year, we hope, and we are really dreaming to welcome you in Switzerland, in Zurich, the 4th of October 2022. Save the date in your agenda, and we'll meet and make face-to-face meeting at this occasion. With that, thank you all and have a good day. Bye-bye.